Hi, I am Danielle Zarochik, a PhD candidate in mechanical engineering at MIT. I am in the Precision Engineering Research Group directed by Professor Alexander Slocum. I aspire to improve world health through the smart design of medical devices. Now, I will share with you my inspirational story of the wound pump, which encompasses the grand challenge problems of health and sustainability. The wound pump expands the application of negative pressure wound therapy to austere environments. Negative pressure wound therapy is the application of a vacuum to an open wound. To apply therapy, there are 3 steps. First, fill the wound cavity with a sponge or gauze, as shown in the upper right-hand corner. Second, seal the wound cavity from its environment using an inclusive wound dressing, as shown in the lower right-hand corner. Connect the wound cavity to a vacuum source using rubber tubing. Then repeat every 3 to 5 days. Negative pressure wound therapy has remarkable benefits. It promotes the blood flow to the wound cavity. It removes interstitial fluid and bacteria, and it increases the rate of granulation tissue formation, which causes less scarring. All of these cause the wounds to heal 3 to 5 times faster than traditional wet-to-dry dressings. Currently, negative pressure wound therapy is not readily available in austere environments. This is because it costs about $10,000 to $20,000 per unit and $40 per dressing. It weighs around 10 pounds, limiting its portability. And it requires upwards of 70 watts of electrical power. Dr. Robert Sheridan presented the great need of negative pressure wound therapy in resource-poor settings for the CIMMYT-sponsored Precision Machine Design course at MIT. During his project proposal, he emphasized the need in the third world setting, where an alarming 55 million patients could benefit. The solution developed was a bellows pump. Let me show you its unique design using the original prototype. First, dress the wound. Then, apply the wound pump. Therapy is now administered. Reset the pump as needed. Air leaks are very critical. However, with the air leak detection system, the seal can last the entire 3 to 5 day period between dressing changes. The key aspect of the wound pump are: it is inexpensive, costing less than $3. It is very portable with no electrical requirement and weighing less than half a pound. And it is sustainable, as the blow molding technology for manufacturing exists in resource-poor settings. After its initial design, the device was approved by the Internal Review Board at Massachusetts General Hospital. The momentum of the project continued after a motivated surgical team from the Brigham and Women's Hospital heard of the wound pump and its IRB approval. Dr. Robert Riviello was at a Partners in Health hospital in Rwanda when he expressed his desire for negative pressure wound therapy in response to the overwhelming number of wounds. While there, he heard about my work and was sure to find me upon his return to Boston. Dr. Riviello, Dr. Gita Modi, also from the Brigham, and myself formed the wound care team. In November 2009, Dr. Riviello took the device back to Rwanda, and it was widely accepted by the medical staff, as its proof of concept was a success. On January 12, 2010, disaster struck in Haiti with a 7.0 earthquake, causing many injuries and many open wounds. The impact was very devastating, and the medical teams on the ground worked hard to provide the most effective treatment to all of the victims. Our team was contacted by a member of PIH who was familiar with the wound pump project. We were asked to provide negative pressure wound therapy, and we were quick to respond. With limited funds, we received many donations to construct our device. Then, 1.5 weeks after invited, we were on a flight to Haiti, along with Dr. Matusik, a Creole-speaking resident, and Jezula, a scrub technician from the Brigham. Our mission was purely humanitarian, and we aimed to treat all wounds that we encountered. In our toolbox was the wound pump, in order to provide negative pressure wound therapy if applicable. We went to the General Hospital in Port-au-Prince, where we treated hundreds of patients. The wound pump was a success on the limited number of applicable wounds. Now, dressings only needed to be changed every 3 to 5 days, instead of the traditional 1 to 3 times per day wet-to-dry dressing technique. This provided more time for the caregivers to attend to other medical needs, increasing the breadth and efficiency of medical treatment. Patients were happier since they did not have to endure the painful dressing changes as often, and patients whose wounds were not quite ready for therapy were already requesting the device. It was an amazing inspirational moment, knowing that my work was making a difference, and seeing the potential to help millions of patients in the future. Thank you for listening and have a great day.